Okay, so I already did some of this. This is about absolute mins and maxes and relative mins and maxes. Okay, so you have this random complex graph right here and a range right here from 0 to 5. If you want to find the absolute max, it is basically just the highest y value that you have in that range. The absolute min is the lowest one that you have in that range. The relative max slash min is where you basically have a change in direction. Okay, so let me redraw this from 0 to 5. So that'd be right here. Kind of like that, right? Okay, so right here would be a relative min, which is also an absolute min, because there's a change in direction right here, and right here as well, because there's also a change in direction. This, however, which is the absolute max, does not count as the absolute max, because that there is no change in direction, because to the left there is nothing. Okay, so there are two critical points, which are relative mins, relative maxes, and points of inflection at x equals 2 and x equals 4.5. Okay, so that is basically what critical points are and what relative and whatever is. Okay, so just for the sake of it, I'm going to go a little bit further and explain concavity. Okay, if you have a graph like this, kind of ugly graph, but from right here to right here, it's separated like that. Okay, so right here it would be concave up because it's going up like a bowl kind of. Well, this one is concave down. This is also concave up. In concave up graphs, you have a minimum, a relative minimum, whereas concave down you have a relative maximum. Okay, so as explained in the second derivative test rule, this only occurs when f double prime of x is less than or greater than 0. This is when f double prime of x is less than 0, and this is also when f double prime of x is greater than 0. Alrighty, and that is concavity and critical points for you.